Engineering the impossible, the future of military tech. What kinds of shifts can we anticipate in the technology used in armed forces over the next 20 years? This question is fascinating in and of itself for many different reasons. More importantly, the answer to this question is essential for making the necessary adjustments to the weaponry of the United States and its allies, as well as military operations, wartime preparations, and the priorities of the defense budget. Hey guys, welcome to Next Tech Ventures. In today's video, we are going to talk about the future of military tech. So stay with us till the end of this video so you don't miss out on any of this information. And before we proceed, don't forget to subscribe to our channel. And let's get started. There is no denying that numerous facets of technology are experiencing rapid advancement, but it is not enough to simply get excited about the potential of the military in the future and wave one's arms around. The stakes couldn't possibly be any higher. The allocation of defense resources needs to be based on a concrete analysis that investigates each of the major military technological invention and innovation categories in order. These categories must be broken down one at a time. The areas in which things are changing the quickest probably merit the most investment, as well as the most creative thinking about how to modify strategies and operational plans to take advantage of new opportunities and mitigate new vulnerabilities that adversaries may develop as a result of these same likely advances. This video, which builds on the methodology used in the book Technological Change in the Future of Warfare, published in 2000, and which was further refined in the paper A Retrospective on the So-Called Revolution in Military Affairs, 2000 to 2020, makes an attempt to look 20 years into the future in order to assist American defense planners with a task that is extremely important. According to our working hypothesis, 20 years is a sufficient amount of time to accurately represent an extrapolation into the future. But at the same time, it is only a relatively brief period of time, which means that the current tendencies in laboratory research can assist us in comprehending the future without requiring us to engage in unbridled speculation. It should not be an overly daunting task to gauge how the world might look in terms of deployable military technology 20 years from now, given that many defense systems take a couple of decades to develop. This strategy is not foolproof, as I'll explain, but it can be still quite useful if it is implemented with the appropriate level of uncertainty acknowledged. An investigation into the current state of affairs as well as projections for the near and distant future of 29 distinct categories of military-related technologies was the primary focus of that book we were talking about. The objective was to make an effort to identify which domains were more likely to undergo revolutionary change over the next 20 years, as opposed to change that would occur at a high or moderate rate. The concept of revolutionary change refers to a pattern and rate of development that renders previously used weapons, strategies, and operational approaches obsolete, while simultaneously opening the door to the development of new ones. My methodology started with an emphasis on the fundamental ideas of physics so that I could better understand the boundaries of what was possible. In addition to this, I combed through the scientific, engineering, and defense literature on a wide range of technological research topics in order to get a better idea of what was most likely to be invented between the years 2000 and 2020. Finally, armed with my own initial estimates of key trends in those 29 areas, I consulted with experts for their feedback and advice, including those working at several of the nation's major weapons laboratories. After completing this research, I then argued in the book that only 2 of the 29 categories of technology were likely to experience truly revolutionary change, and as a result to create the potential for a military revolution when combined with other types of available technologies as well as new operational and strategic concepts. These 2 spheres, namely computer hardware and computer software, were forecast to experience revolutionary development. As I discussed further in the concurrent paper titled A Retrospective on the So-Called Revolution in Military Affairs 2000 to 2020, I have come to the subsequent conclusion that I was correct about computers, but that I should have added robotics to the list of technologies likely to experience radical change. My earlier estimate in the year 2000 forecast a high pace of change for robotics, such as unmanned aerial vehicles, rather than revolutionary progress. There are now approximately 20,000 unmanned vehicles of various types in the inventory of the Department of Defense. It's remarkable that these vehicles have been put to a variety of new uses throughout this century, from Iraq and Afghanistan to the wider Middle East and beyond. Robotic technology is also being utilized more and more by hostile forces. I should have also emphasized the degree to which advancements in computing would create vulnerabilities, as nations are increasingly using computer systems and software that create potentially gaping weaknesses in their military capabilities. This particular point turned out to be a significant enough one that, looking back, I should have emphasized it in a manner that was distinct and unique from the others. Therefore, in my earlier taxonomy, I had one significant area of technology where I underestimated the potential for revolutionary advancement, and another area where I should have emphasized additional dimensions of likely change. Both of these errors were my fault. In the earlier book, I made the prediction that 7 additional categories of technology would likely experience high levels of change in the near future. These 7 categories are as follows: chemical sensors, biological sensors, radio communications, laser communications, radio frequency weapons, non-lethal weapons, and biological weapons. The remaining 19 categories of key military technologies appeared likely to advance at only modest or moderate rates. Many of these remaining technologies were sensor technologies or major components of weapons platforms such as ground combat vehicles, aircraft, ships, and rockets. In the concurrent paper I'm working on, I go back and look at each of these forecasts again. In general, the gist of my estimates appears to have been mostly accurate, despite a number of specific imperfections in which the progress that I had forecast to be high or rapid turned out to be only moderate or vice versa. However, in general, my estimates were mostly on the right side. With the exception of robotics, I do not believe that any of the remaining 26 areas of technology have actually undergone revolutionary change. And this is an extremely important point. Modern militaries have struggled with computers. They negligently built Achilles heels into their own systems and national civilian infrastructure, which is fundamental in modern military operations. Thus, future weapons may be less reliable than before. In other words, they may have put themselves back, though it's impossible to know for sure, since we haven't witnessed the interstate combat between near-peer competitors needed to examine the idea accurately. Those in the classified world may know more about cyber vulnerabilities and opportunities than I do. Even so, cyber vulnerabilities aren't static. They evolve in a game of measure and countermeasures faster than electronic warfare. Even when vulnerabilities are known, cyber attack ripple effects are typically difficult to predict. Different types of failures may affect a bigger system in different ways. Individual vulnerabilities make evaluating these possibilities challenging. Complex concepts and vast military institutions make future predicting difficult, as we just said. Scientists can generate new skills that are partially projectable and foreseeable over a 20-year time horizon based on their current research efforts in modern science and engineering. When combining technologies into systems and operational concepts that can help fight wars, the human dimension of organizational performance, influenced by the external combat environment as well as domestic and bureaucratic politics, introduce new variables, as Stephen Rosen, Thomas Earhart, Barry Posen, Stephen Biddle, and others have written. The 1990s RMA discussion highlighted the fact that while technology can provide the raw materials for military revolutions, they must be launched by entrepreneurship and organizational adaptation. This was true in the 1930s and 40s with blitzkrieg, integrated air defense, aircraft carrier operations, amphibious assault, anti-submarine warfare systems, and the atomic bomb. Still true. My general conclusion is that military-relevant technical progress may be faster and more impactful in the coming 20 years than in the last 20. Rapid computer innovation may make the next 2 decades more transformative than the last 2. Robotics and cybersecurity may intensify, modern militaries may use them more, and they'll likely extend into AI. Well, that brings us to the end of today's video. Feel free to let us know what you think about it. And if you like the video, please leave a like and subscribe to our channel for more amazing content. Thanks for watching, and we'll see you next time.